It's 4.5, integration by U substitution. This, I don't want to say it's one of the harder things we do. We do spend some time on it though, because it's, once you get the hang of it, it's not bad, but it's like you got to do a bunch of these before you get the hang of it. Maybe I'll put it that way. It's basically figuring out how to undo the chain rule. Right? The chain rule forward isn't too bad as long as you remember it. Right? One layer at a time, derivative of the inside, and keep multiplying them together. It's not as straightforward going backwards. Let me give you're not going to know what this means yet, but this is the overall rule of thumb here is to pick U so that du is part of the integral. Again, that doesn't really even make sense to you yet, but that's okay. Let's jump in and do some examples. We're undoing the chain rule. We're going to pick U so that du shows up as part of the example, or as part of the integral. So the integral of 2x times x squared minus 1 to the fifth dx. Right, well, your first reaction should be, that looks terrible. How am I supposed to integrate that? Other than, I guess, you could fifth this thing out, which would be awful, and then distribute a 2x and then use the power rule. So that would be one way to go, but that's really not our favorite way to go. But if I pick u wisely, I want to let u equal something in the integral so that du shows up. And again, I don't know how to do this other than do some together, and you watch me pick some, and you start to get the pattern of what's happening here. If I let u be x squared minus 1, then the derivative of u, what's the derivative of x squared minus 1? 2x. Now, really we should say du dx is 2x. And then if we move that dx over, which we've not really done before, like, whoa, wait a minute. Du dx meant u prime, and now we're like moving it out of the way to the other side. But now 2x dx combines to make du. And u was x squared minus 1. So I'll replace x squared minus 1 with u. And magically, because I picked a good value of u, I have a pretty easy antiderivative to do now. This is just a power rule thing. Increase the power by 1, divide by the new power, plus c. Now, I'm not quite done because this problem started with x's and I've got something with u's. So I need to replace the u with x's. So 1/6 x squared minus 1 to the 6th. Plus c. Depending on how good you are with derivatives in your head, you could check this one. 6 times a 6 would go away. We decrease the power by 1 to get to 5. So that would leave x squared minus 1 to the 5th. And then chain rule, the derivative of x squared minus 1 is where that 2x came from. Yes, no? Not yet? Got a couple yeses, a couple no's, a couple of not sure yet. This is hard because you just got to practice until you get used to figuring out oh, if I pick that for u, then du shows up, and it makes this problem a lot easier. The integral of 3x minus 2 to the fourth dx. Well, this is only example 2, so I don't really expect you to know what we should pick for u, but any guesses based on the...
3x minus 2.
Let's do 3x minus 2. Let's say that u is equal to 3x minus 2. So du dx then is just 3. So we're kind of close. Here's the good news. You can fix constants, right? You can slide constants or negatives inside and out however you want to. So if I want to make this thing work, I'd really like that to be 3 dx. And I'm allowed to do that as long as, I can't do just that because that'd be wrong. But if I put a 3 inside, what could I put outside that would just balance it out? A third. So put a 3 inside to make du show up. But then I put a 1/3 outside, so I didn't change anything. I wanted a 3 there so that this would work. So now I've got 1/3 integral of u to the fourth du. So we've done the hard work. Now we've got the easy work, what should be the easy work. Increase the power by 1, divide by the new power. 1/3 still out there. Plus c. And then don't leave that because the answer or the problem started as an x problem. We need an x answer. So 1/15, 3x minus 2 to the fifth plus c. And again, if you wanted to check your answer, you could take a derivative of this and see if you got back to our original. 5 times the 15th would get you to a third, and then eventually you'd chain rule and show up with that 3, and the 3 times a third would make that stuff go away, and you'd be back to just 3x minus 2 to the fourth. Integral of the square root of 5x plus 4 dx. Thoughts on what u should be? Yeah, let's let u be 5x plus 4. And I'm going to rewrite that as u to the 1/2 because that just makes things a little bit easier. Why don't you see if you can take it from there? So this one's really similar to that last one. It needs to be fixed so the dx or the du shows up. There's the first couple of steps if you want to check and see how things are going. So u to the 1/2, I can handle that. Increase the power by 1. Divide by the new power, but I don't want to divide by 3/2. Rather multiply by 2/3. That 1/5 is still out there. Plus c. Let's see, that would be 2/15. U was 5x plus 4 to to the 3/2 plus c. Again, not that you would do it. I'm going to do it on this one. If you took the derivative of that thing, so that would be 2/15 times 3/2 times 5x plus 4 to the 1/2, right? Bring the power down, decrease the power by 1, times chain rule times 5. That should be back to where I started. So that's a lot of mess there, but the 2's cancel. 3 times 5 is 15, so that cancels. And all of that's left with the square root of 5x plus 4, which is where we started this problem a few minutes ago. So you can always check them. It's usually the chain rule that you're trying to handle with U substitution. The integral of 2x squared times the square root of 1 minus 4x cubed dx. That's terrible, right? There's no way to antiderivative that thing, except that we can use U substitution. So what do you think would be a good pick for you? Let's go with 1 minus 4x cubed. By the way, you guys are picking them right, and it helps that I'm guiding you, but a lot of times on U substitutions, you pick wrong the first time, and things kind of go astray, and you're like, okay, I got to back up and start over and pick a different U.
Wait, so would the U include the square root or not?
That's a really good question. Should the U include the square root? And, I mean, I know the answer because I've done 100 of these, but you don't know the answer yet. And so if your first attempt is include the square root, you could, in fact, let's say U was included the square root. You don't have to write this down because I know it's wrong, but you don't know that initially. So let's say you include the square root because you're not sure. Then du would be 1/2 1 minus 4x cubed to the negative 1/2 times, what would that be, negative 12x squared. So I don't see, I mean, I see an x squared, so that's nice, but I don't see this thing anywhere. So that means we bit off a little too much for you on that problem. So let's back up and let u just be 1 minus 4x cubed. Then du would be negative 12x squared. You're going to get in the habit of just putting the dx on the other side because that's where you want it anyway. Okay, that looks helpful because now we've got this piece taken care of. So that's u to the 1/2. I would like negative 12x squared. I've got 2x squared, so that's pretty good. Right? I can fix constants. I can't fix x's. So you can't put an x, on the inside and a 1 over x on the outside. You can't do that with variables. You can do it with numbers, but not with variables. So what do I need to multiply this by to fix it, to make it match this? Negative 6. And that means I need a negative 1/6 out front. And now if I tie all of my orange stuff together, that makes du. And the small price I had to pay was now there's a negative 1/6 out front. See if you can finish it from there. So increase the power by 1, divide by the new power. Well, actually, you wouldn't have to simplify that. You can safe stop and not even worry about it. Leave it as negative 1/6 times 2/3. You can't leave u to the 3/2 though, because this problem started with x's, so we got to finish it with x's. So u was 1 minus 4x cubed to the 3/2 plus c. Yeah, something's not right. That minus sign? Yeah. So that would be what, 1/9 if I reduced it? But I don't have to reduce it. Safe stop. Alright, this is just all about getting practice at recognizing what makes a good pick for you and what doesn't. And sometimes you'll make the wrong choice. I'm going to set this one up a little bit differently, but it's really the same thing. Solve for y if dy dx equals 7x over the cube root of 2x squared minus 1. Again, it looks terrible. Like, how in the world am I supposed to work this problem? Well, let's first talk about how it's set up differently. Solve for y. So I've got y prime on one side. So how do I get from y prime back to y? Integrate. So the integral of dy dx would just be y. So that was sort of the only extra wrinkle to this problem. I guess that dx should move to the other side there. And once again, it's all about figuring out what u is. So what do we think? Based on the admittedly few examples you've seen, let's try 2x squared minus 1. So you want to make it as big as much of the stuff as you can, but you don't want to make it too much, because if you make it the cube root, then think ahead. Like your derivative, if you let u be the cube root, then your derivative is going to be 1/3 times all that to the negative 2/3 times the derivative of the inside. Like, you're going to have a mess. So let's let u be 2x squared minus 1. You want to let u be as much as you can without creating a mess on your hands. So du then would be 4x du, or dx, excuse me. Let's see. So I've got u to the 1/3 in the bottom now. Took care of that. That 7 is kind of messing with me here. Rather than figure out what do I have to multiply to 7 to get to 4, you can do it that way. I'm just going to forget that. I'm just going to take the 7 out front. That's messing with me. I don't want to deal with that. And if it's just a number, slide it out front. What number would I like there instead to make this work? A 4. So let's put a 4 there. Of course, that means we need a 4 in the bottom out front. Should be more careful about where my circles went, but 4x dx is du. So this one had an extra constant to play with, that 7. I also don't like the 1/3 in the bottom. That really messes people up because they think, oh, I'll increase the power by 1 and get the 4/3. Well, yeah, 1/3 plus 1 is 4/3, but that's not really the problem here. That's u to the negative 1/3. So now that would be, if I add 1 to that, I get u to the 2/3, which means I need a 3/2. And again, safe stop means I don't have to multiply those. I can just leave them both there. Plus c. So 21 over 8 if you want to. If you don't want to, that's fine. Leave them like that. 2x squared minus 1 to the 2/3 plus c. Practice on U substitution. We're going to do a few more examples, but this is important that you do. I mean, you can do all the homework all the time, but especially important for this. Otherwise, you're just going to be stuck not knowing how to pick. How to pick a good valued U. How to pick a good amount of stuff to be U. Alright, let's do another one that's set up this way. dy dx equals x plus 2 over square root of x squared plus 4x minus 5. We have y prime. If we want y, we should integrate both sides, which sort of brings us to the point of this problem. Yeah, and how about this for a safe stop, right? I got y equals, aren't I good? Well, no, because that's not calculated already. There's still more calculus to do. You wouldn't leave that as a safe stop, but I don't think. So, guesses? Lots of stuff going on in there. Guesses for what u should be? Okay, let's try x squared plus 4x minus 5. And then we'll know if that's a good pick if du looks good, like shows up. So derivative of x squared plus 4x minus 5 would be 2x plus 4 dx. Well, yes and no. Hassan? What did you say? Okay, so be careful. All of those could be correct. Something with a 2. I need this to be 2x plus 4, so I'm almost there. I'll put a 2 on it and then divide by 2. And that will make this whole top piece du. And the only price I had to pay was to put a 1/2 out front. I'm going to go ahead and write that as u to the negative 1/2. Because denominators and square roots both would mess me up, potentially. So I've done all the hard work now. Now this is supposed to be an easy integration now. Increase the power by 1. Divide by 1/2. That would be multiplying by 2. There's also a 1/2 out front. Plus c. Not quite done yet. Not because 1/2 times 2 is 1. Like, you could still leave that if you want to. I mean, I'm all in favor of safe stops, but I'm going to go ahead and do 1/2 times 2. And it's u to the 1/2, so x squared plus 4x minus 5 to the 1/2 plus c. If you're checking Calc Chat, it's a book assignment today, they're probably going to rewrite that as a square root, but I think you've seen enough 1/2s and square roots to be okay with either one of those. All right, we don't want a day to pass without doing some trig, right? Three more. These will go reasonably quick if you know your trig. Integral of the cosine of 4x dx. Ideas for what u should be?
Cosine of 4x.
Okay, let's try that. If u is cosine of 4x, then du is negative sine of 4x times 4. What do we think about that?
dx.
What's that?
Times dx.
Times dx. So that would mean we've taken care of the cosine of 4x, and the only thing left, I'm grabbing a pencil, it should be a clue as to what's happening here. Like if that's u, this, I got nothing with signs in it. So I think we bit off too much for u, because du isn't showing up. I don't have any things with signs in it. And I'm not allowed to multiply by sign and divide by sign out front. That doesn't work. That's only for numbers. So it wasn't a bad guess. It just wasn't right for this particular problem. So we try again. Let's try 4x. Much simpler. Du then would be 4 dx. Okay, I can make that happen. Right? I can stick a 4 in there on the dx and a 1/4 out front. So 1/4 integral of cosine of u du. Okay, well that looks a lot nicer, because the integral of cosine is negative sine. So negative 1/4 sine of 4x plus c. Some people would not use u substitution on that one. Some people, let me show you what the original problem was again. Integral of cosine of 4x dx. They would say, well, I can undo cosine to get a negative sign. The 4x has to be the same. And the chain rule would give me a 4, but I don't have a 4, so I'll put a 1/4 out there to like cancel it out. So if it's simple enough, you can kind of bypass u substitution if you can think backwards about the chain rule. All right, now for some real fun. The integral of sine cubed of x times cosine of x dx. I want to pick u so that du shows up. So what do you think? Okay, so if we pick, I'm not going to write it down because it's not right. It's a good guess. It's one of the two. If you let u be cosine of x, then du is sine of x. So that's pretty good, except that we have sine cubed, and we don't want to like have our du cubed. Like that would not be a good situation. So instead of letting u be cosine of x, let's let u be sine of x.
Is sine of x not sine cubed of x?
Correct. I'll write it down and show you what happens. If you let u be sine cubed of x, then the derivative of that is 3 times sine squared of x times cosine of x. Right? And so the cosine's nice. So you'd have the cosine taken care of, the sine cubed taken care of, but you'd have this extra cosine of x. What do I do with that? So let's don't do it that way. That's too much. So again, you got to figure out, well, I want u to be as much as it can be, but if I pick too much, then du is too complicated and it doesn't work. If I pick u to be sine, du is cosine of x dx. Keep my color scheme the same here. So cosine of x dx, that's du. And sine of x we said was u. So we didn't take care of the cube, but I can integrate the cube. I can handle that. right? So don't let u be everything. You need leave something for you to integrate, because that'll make life a little easier. I didn't even have to fix a constant on this one. So u to the 4th over 4, which would be 1/4 sine to the 4th x plus c. And not that you would do this very often, but you could check that by taking a derivative. Let's see, so that'd be 4 times sine cubed of x, because we decreased the power by 1, and then chain rule would be times cosine of x. And yeah, that's what we started with. So u substitution allows you to handle the chain rule, to go backwards on the chain rule. All right, last one. Again, we'll see if we know our trig derivatives well. The integral of tangent squared of x times secant squared of x dx. In my notes, I have things written in pencil here because I've made the mistake before on this one. So what could we pick for u that's complicated but not too complicated, and that makes du show up in our integral over here? If we pick u to be tangent, what's the derivative of tangent? Secant squared. So that's probably a good pick. So let's let u be tangent of x. Not tangent squared, because if I pick tangent squared, then the derivative is 2 tangent x secant squared x. That's too much. I don't want all that. I really want to, if I let u be tangent, not the squared part, just the tangent, then du secant squared x dx. Perfect. That's exactly what's left. And what am I taking the integral of? U squared. So be careful. I've replaced, or I let u be tangent, but that squared is still there. But that's okay. I can integrate a squared. I just can't integrate a squared and a tangent and a secant squared all at once. So u cubed over 3 plus c. So 1/3, and then u was tangent, so tangent cubed x plus c. And again, you could take a derivative if you wanted to check it. I'm not going to do it, but it wouldn't be too bad. 3 times a third would go away. Decrease the power by 1, you get the tangent squared. And then chain rule, derivative of tangent is secant squared. So just kind of a mental check on that one, that it works out. So these are hard. Block day, Friday, Monday. 3 days on practicing u substitution. So if you have some false starts today, it's expected, it's understandable. Even when I get a new one, a hard one, like you just got to try one and see if it works. And if it doesn't work, back all the way up and change your guess for what u is. Or u was. I don't know how to phrase that. Page 301, 7 through 29, every other odd, and then 39 and 41. Let's see if any of those look crazy, or any crazier than we already know about. We don't have any flag to go over, so let's see. 7, 11. Yes, sir. Yeah.
Do I need a pass?
Nah. Yeah, I think those are all, none of them are easy, but there's nothing too far different than what we did in the notes.